Welcome, everyone, to TechDaily.ai. I'm your host, David.
And I'm your guest, Sophia.
You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit TechDaily.ai to get started today.
Yeah, it's a great way to get your message out there.
Definitely. So, I want you to picture the ultimate future of artificial intelligence. Just kind of close your eyes and imagine it.
Right, like what's the end game, basically?
Exactly. Because if you listen to the dominant narrative in the tech industry today, you are probably imagining this, like massive, all-knowing God in the cloud.
Oh, for sure, the giant centralized superbrain.
Yeah, just sitting in some colossal data center, right? Consuming endless amounts of power. And it's basically capable of answering every possible question or solving every problem on Earth.
That's the dream they're selling.
Right. And the underlying belief there seems to be that intelligence scales in this perfectly straight line. Like, you just dump in more data, you plug in more advanced chips, pump in more electricity, and boom, the model gets smarter.
Yeah, and the assumption is that once it's smart enough, all those massive economic costs will just magically disappear.
Exactly. But today, we're going to explore why that might be entirely wrong. Because if you look at the research, that obsession with raw, bleeding-edge intelligence looks like a massive economic trap.
It really does. It's almost like a religion in Silicon Valley right now.
We're going to get into why AI is absolutely nothing like traditional software and why most valuable AI of the future actually won't be that giant superbrain in the cloud.
Right. It's going to be something much smaller, way cheaper, and highly localized to your specific needs.
So let's start with that industry obsession. You called it a religion.
Yeah, I mean, the entire industry is just fixated on raw IQ right now. If you look at the data, you see this relentless optimization for abstract benchmarks.
Like test scores and stuff.
Exactly. Standardized test scores, coding speed, and what they call parameter counts.
Break that down for us. What exactly is a parameter in this context?
Sure. So when developers talk about parameters, they're essentially talking about the artificial synapses inside the model's brain.
Okay, so more parameters means a bigger brain.
Right. The assumption is that if you cram more of these synapses into a massive model, it will just automatically produce the most useful, dominant product in the market.
But that's a huge assumption, right? Because as an everyday user, or, say you're a corporate executive managing 1,000 employees, you don't actually care about abstract intelligence.
No, not at all. A massive model scoring in the 99th percentile on a, synthetic biology exam, that does not help a logistics company track a delayed shipping container.
Businesses don't pay for an IQ score. They pay for systems that actually understand their unique customers. They need it to understand their internal workflows.
Exactly. The messy reality of how work actually gets done on a random Tuesday afternoon.
It kind of feels like the biggest tech companies are locked in this arms race to build a multi-million-dollar Formula One race car.
Oh, that's a great way to put it.
And they're assuming everyone is going to buy one. But most businesses look at that Formula One car and say, we just need a reliable delivery van to drop off packages.
Right. They just need something practical.
And if the AI equivalent of a delivery van is becoming practically free, chasing that Formula One model seems like a losing strategy.
It really does. And the dynamic is actually even more severe than just a difference in, vehicle types.
How so?
Well, look at the numbers from the Stanford 2025 AI Index. They reveal this staggering shift in the barrier to entry.
Okay, what did they find?
They found that the cost of running an AI model with, say, GPT 3.5 level performance, that cost plummeted by more than 280 times.
Wait, 280 times cheaper?
Yes, between late 2022 and late 2024.
Wow, a 280 times drop in cost over just 2 years. That completely rewrites the rules of the game.
It really does. That means your delivery van isn't just getting cheaper, the cost is essentially approaching zero.
So you don't need a billion-dollar research budget to utilize that kind of capability anymore.
Not at all. Furthermore, the Stanford research highlights the rapid rise of these things called open-weight models.
Open-weight models.
Yeah. So historically, the smartest models were locked away in corporate vaults, right?
Okay.
You could only talk to them by paying a toll to a tech giant's cloud server.
Right, like a subscription fee or paying per prompt.
Exactly. But open-weight models completely flip that script. Developers can actually download the finalized weights, which are the dialed-in settings and parameters that make the model smart, and they can run it on their own hardware.
So completely independent of the big cloud providers.
Yes. And in just 1 year, these open-weight models have closed a massive amount of the performance gap with the huge proprietary systems.
So not only are the basic models incredibly cheap, but these community-driven, downloadable models are catching up to the trillion-dollar proprietary ones for everyday tasks. But that brings up a pretty glaring question for me.
Yeah.
If these highly capable models are getting incredibly cheap and you've got millions of users interacting with them daily, these tech companies must be printing money, right?
You would think so.
Like during the traditional software boom.
Yeah.
You write the code once, duplicate it for 1 million users at zero cost, and just watch your profit margins explode.
Well, see, that is the trap. Applying the traditional software business model to AI is a fundamental misunderstanding of what is actually happening under the hood.
Really?
Yeah. We are confusing artificial intelligence with software as a service, or SaaS.
Okay, break that down for us. Why is it different?
So the classic SaaS dream works because it has high fixed costs, but incredibly low marginal costs.
Right, you pay developers a bunch of money up front to build the app.
Exactly. But then serving the millionth customer costs you almost nothing. You're just duplicating a digital license. AI completely breaks those economic rules.
See, I'm struggling to see why it breaks the rules. Because for you, the listener, sitting at your computer, it looks exactly like software.
It does look like it, yeah.
When I open a chat window on my browser, I'm just typing text into a digital box. It feels like software.
Right. The interface is a digital box, but the mechanism generating the response is brutally physical.
Physical.
Yes. With traditional software, clicking a button just retrieves static info from a database. But with AI, every single prompt you type, every summary it writes, every image it generates, it triggers a process called inference.
Inference, okay.
Inference is the act of the model actively calculating an answer by pushing your question through all those billions of artificial synapses we talked about earlier.
Ah, so it's doing heavy math every single thing.
Exactly. And that calculation consumes physical processing power. It burns server time, it monopolizes graphics processing units, and it draws massive, massive amounts of real electricity.
So AI is definitely not a build once, sell infinitely kind of business.
Not at all. It is a physical utility.
Wow. So it's kind of like building an amusement park, where instead of just charging an entry fee at the gate, the park operator has to pay a massive separate electric bill every single time one person rides the roller coaster.
That is a perfect analogy, yes.
Which means if you price the entry ticket too low, growing your user base could literally bankrupt you.
And that physical cost burden is exactly why the underlying economics looks so incredibly dangerous right now. Technical scaling, making a model bigger and smarter, is not the same thing as economic scaling.
Right, because a larger model performs better, but it's exponentially more expensive to run.
Exactly. The physical infrastructure build-out required to support all this is unprecedented.
So how big are we talking?
Well, Goldman Sachs estimated that annual AI expenditure could jump from $765 billion in 2026 to $1.6 trillion by 2031.
1.6 trillion. That is insane.
Yeah. We are not looking at a software cost curve here. We are looking at an infrastructure mega project.
Which actually explains why the companies making all the money right now aren't the ones building the consumer chat apps. The real revenue is flowing straight to the hardware layer.
Oh, absolutely. The numbers coming out of the hardware sector are just staggering. Just look at NVIDIA.
Oh yeah, they've been on a tear.
They reported fiscal year 2026 revenue of $215.9 billion.
$215 billion.
Yeah, which is a 65% year-over-year jump. And in just their first quarter of fiscal 2027, revenue hit $81.6 billion.
In one quarter.
In one quarter. And over $75 billion of that came strictly from data centers.
Wow. So that completely reveals the true structure of the current boom. The companies dominating AI aren't really software companies at all.
No, they're compute brokers. They are essentially renting out access to scarce physical computation.
They're acting as this weird hybrid between a cloud provider, an energy company, and a massive semiconductor buyer.
Right.
And looking at this market structure, honestly, it feels dangerously similar to the dot-com bubble.
Oh, the parallels are definitely there.
Because back in 2000, the internet was a very real, transformative technology. Fiber optic cables were real. E-commerce was a real thing.
Absolutely.
But the assumption that web traffic would magically fix terrible business models led to a massive collapse. AI seems to be in that exact same danger zone.
I agree completely.
Tech is real, but assuming that massive centralized AI can scale economically like a traditional app, it seems fundamentally flawed.
It is flawed. However, a lot of folks in the industry will argue that the hardware is just going to catch up.
Right.
They believe that as AI ships and algorithms become more efficient, the cost of that inference will drop and the infrastructure problem will just, solve itself.
I mean, that seems like a logical progression, right? If we make the chips better, the roller coaster uses less electricity, the costs go down, and the problem goes away.
It seems logical until you look at how human behavior actually responds to efficiency.
What do you mean?
There's this fascinating kind of counterintuitive economic concept from the 19th century called the Jevons paradox.
The Jevons paradox.
Okay, I'm intrigued.
So in 1865, this British economist named William Stanley Jevons was studying the coal industry.
Okay.
Engineers had just figured out how to make steam engines significantly more efficient at using coal.
So they needed less coal to run?
Exactly. The natural assumption was that Britain would start consuming less coal overall because the engines didn't need as much fuel to do the exact same amount of work.
Right, it's like better gas mileage. You get a Prius, you don't have to visit the gas pump as often, you save fuel.
But the exact opposite happened.
Really?
Yeah. Because the efficiency made coal-powered activity dramatically cheaper, it suddenly became economically viable to put steam engines everywhere.
Oh, wow.
They put them in more factories, more machines, more transportation networks. The efficiency didn't decrease demand, it caused demand to explode.
So Britain consumed massively more coal.
Massively more. And AI is following that exact historical pattern today.
Okay, I see where this is going. Yeah, if engineers manage to drop the cost of a single AI query from $1 down to 1 cent, companies aren't going to just pocket the 99 cents and walk away.
No, of course not. They're going to embed AI into absolutely everything.
Exactly.
It won't just be drafting an occasional email anymore. It will be actively monitoring every single meeting note. It'll be analyzing every spreadsheet in real time.
Routing every customer service ticket.
Right, rewriting code on the fly.
Exactly. So the cost of an individual query falls, but the total volume of queries skyrockets. And consequently, overall compute demand continues to surge.
Which leads directly back to that massive physical bottleneck we were talking about.
Right. The International Energy Agency actually tracks this. They project that global data center electricity consumption will roughly double to around 945 terawatt hours by 2030.
945 terawatt hours. That's hard to even picture.
It's massive. They expect it to grow 15% every single year from 2024 to 2030, and that's driven heavily by this AI demand.
Wow. But if demand is growing that fast, we run into the reality of the physical world. You can write and deploy software code overnight,
Sure.
but you cannot build a new nuclear power plant or lay thousands of miles of copper wire by next Friday.
No, you definitely cannot.
So are we literally going to hit a wall where we run out of electricity before this sci-fi AI future even arrives?
We're already hitting the physical limits of the supply chain, honestly. Like you said, you can't iterate physical infrastructure the way you push an update to an app.
Right.
The bottlenecks are everywhere. It's the power grids, it's the specialized cooling systems for the data centers, and it's the manufacturing of the chips themselves.
Yeah, let's talk about the chips.
The manufacturing dependency there is terrifyingly concentrated. A 2025 report from the U.S. International Trade Administration noted that Taiwan accounts for more than 60% of global foundry revenue.
60%.
Yeah, and a staggering 90% of leading-edge chip manufacturing.
Wait, 90% of the most advanced chips in the world are coming from a single island. That is an unbelievable single point of failure for an entire global industry.
Oh, and it gets even narrower than that.
How is that possible?
Because to manufacture those leading-edge chips, the foundries rely on EUV lithography system.
EUV.
It stands for extreme ultraviolet. These machines are incredible. They use lasers to vaporize microscopic droplets of tin 50,000 times a second.
You're kidding.
No, and they do that to generate a highly specific wavelength of light. Then they use that light to carve microscopic three-dimensional pathways into silicon.
That sounds like science fiction.
It's essentially like trying to draw a detailed map of New York City on the head of a pin using a flashlight.
That is wild.
And here's the kicker. There is only one company on the entire planet that makes these machines. ASML.
Just one company.
Just one. And the machines cost hundreds of millions of dollars each. So you cannot simply move fast and break things when you are dealing with multi-year construction timelines for fabrication plants and, hard limits on local water supplies for data center cooling.
Okay, so let me summarize where we're at. We have this wildly expensive, physically constrained infrastructure that the tech giants are pouring literally trillions of dollars into.
Correct.
Which brings us to the ultimate reality check. The businesses that are actually paying to use this technology. Because if you listen to the marketing, every corporate office is supposedly turning into this hyper-efficient automated utopia.
Right. The marketing is very aggressive.
But given all the massive costs and bottlenecks we just discussed, how is that translating to the actual enterprise level?
Well, the data reveals a brutal disconnect between the vendor marketing and the reality on the ground.
Okay, what do the numbers say?
A global survey run by McKinsey in 2025 found that 88% of organizations were regularly using AI in at least one business function.
88%. So the adoption rate is massive.
Mhm.
Basically, everyone is experimenting with it.
Right, but experimenting is the easy part.
Yeah.
Turning that into actual revenue or cost savings is where it gets incredibly difficult.
So what's the success rate?
Out of that 88% utilizing the technology, only 39% reported any actual enterprise-level impact.
Less than half.
Less than half.
Yeah.
And the numbers get even more sobering when you look at direct return on investment. MIT NANDA released a State of AI in Business report in 2025.
Okay.
They specifically tracked the $30 to $40 billion invested into enterprise generative AI.
That's a lot of money.
A ton of money. And they found that 95% of organizations in their data set were getting zero measurable return on that investment.
Wait, 95%.
95%.
So they invested billions and got zero measurable returns.
Zero. Only 5% of integrated pilots actually produced meaningful business value.
I really need to wrap my head around this.
Yeah.
We are talking about arguably the smartest, most capable technology ever created by humans.
Yep.
Companies are pouring tens of billions of dollars into integrating it into their workflows, and 95% of them are seeing zero measurable return.
That's what the data shows.
But, I mean, the generic chatbot on my phone seems incredibly smart. How is it failing so miserably inside a corporate office?
The failure stems from treating AI like a standard SaaS product that you can simply plug in and turn on.
What do you mean?
You can't just slap a generic high IQ chatbot on top of a messy enterprise and expect transformation. Think about how a legacy company actually stores its data.
Oh, it's usually a nightmare.
Exactly.
Yeah.
It's siloed departments, messy SharePoint folders, unstructured PDFs from a decade ago, plus all the strict compliance rules.
Right.
A massive generic cloud model doesn't know your specific HR policies from 2018. It doesn't have the security clearance to read your client's non-disclosure agreements.
Right. It doesn't have the permissions.
And it certainly doesn't know which middle manager has the actual authority to approve a budget override on a Friday afternoon.
So the model might be an absolute genius at quantum physics.
Yeah.
But if it doesn't know where the digital files are actually kept or who to route them to, it is entirely useless to an accountant trying to close the books at the end of the month.
Exactly. It's a fundamental lack of context, and context completely overrides raw IQ in almost every enterprise scenario.
That makes total sense.
I mean, a worker might save 10 minutes having a chatbot draft a polite email, but organizations do not run on isolated 10-minute tasks. They run on permissions, legacy databases, and complex handoffs between different departments.
So the AI needs to understand all of that.
Right. The most valuable AI is the one that acts like a highly competent, deeply embedded insider, not a generic, omniscient genius floating in the cloud.
So the bottleneck for businesses isn't that the models aren't smart enough. The bottleneck is that their own internal data is too messy to integrate.
Bingo.
Okay, so if putting everything in the cloud is physically bankrupting the tech giants with electric bills, and massive centralized models are failing to actually help 95% of businesses,
Yeah.
something has to snap.
The current architecture itself is broken, yes.
I'm picturing like a triage desk at an emergency room.
Okay.
You don't send every single person who walks through the hospital door straight to an MRI machine or to the top specialist.
Mm-hmm.
A triage nurse, which would be a smaller, cheaper system, sorts the request, handles the basic stuff like a sprained ankle, and only passes the really complex problems up the chain. Is that kind of the blueprint the industry is moving toward?
That is exactly it. The industry calls that approach model matching, or sometimes orchestration.
Model
Yes.
matching.
The vision of a single giant model handling every single query from the cloud is being replaced by a layered, highly orchestrated ecosystem. You intelligently route the workload across a portfolio of different models, matching the size and the cost of the AI tool to the specific complexity of the job.
So you still keep the really expensive, massive frontier models for the heavy lifting, but you surround them with cheaper alternatives.
Exactly. You absolutely still utilize those massive frontier models, but you reserve them for tasks that actually require that level of heavy compute. Things like complex reasoning, scientific discovery, or high-level strategic synthesis.
But for routine stuff,
For routine, everyday tasks, you route the prompt to a small, highly efficient model. For sensitive internal data, you run a local model. And you employ retrieval systems to constantly pull and double-check facts against your own secure internal documents.
taking that triage analogy a step further, it's literally like staffing a hospital. You don't pull the chief of surgery out of the operating room and pay them a massive hourly rate to validate parking tickets in the lobby or wipe down the cafeteria tables.
No, you would go bankrupt doing that.
You route the administrative tasks to the administrative staff.
The financial waste of using a trillion-parameter model to summarize a basic meeting agenda is exactly like paying a surgeon to wipe down tables.
Wow. Felt like that. It sounds crazy that we've been doing it this way.
It is. Think about it like this. A modern hospital might use a massive frontier cloud model for advanced medical research, or synthesizing complex drug trial data.
Right, the really hard stuff.
But for a patient filling out an intake form in the waiting room, they use a small, localized system that handles scheduling and policy searches quickly and cheaply, without ever sending that sensitive medical data to the cloud.
Which is huge for compliance.
Exactly. Or consider a large law firm. They might utilize the frontier model to analyze a complex legal precedent for a massive corporate merger.
But what about their private emails?
Right. When it comes to summarizing highly privileged, sensitive client communications, they rely on a private, secure model running entirely on their own internal offline servers.
This shift toward handling sensitive data in-house seems incredibly important. If cost and privacy are the primary concerns for businesses, the intelligence literally has to move out of the cloud and directly onto the devices sitting on our desks.
And that physical migration is already underway. It is driving a massive shift toward local AI.
Local AI, like on our actual computers.
Yep. Gartner released a projection in August 2025 tracking the rise of AI PCs.
What makes it an AI PC?
These are computers specifically designed with built-in neural processing units, so they can run AI models locally without needing an internet connection at all.
That's awesome.
And Gartner predicted that AI PCs would capture 31% of the total global PC market by the end of 2025.
31%.
Yeah, that equates to roughly 77.8 million units shipped.
That is a massive shift, because when you run the model locally on your own laptop, you completely bypass the cloud. You aren't triggering that expensive inference cost on a remote server every time you ask a question.
Exactly. You get zero latency. It functions perfectly when you are completely offline on an airplane. And most importantly for the enterprise, it guarantees total data privacy for regulated workflows.
So the entire architecture of the technology changes.
Completely. AI stops being this expensive oracle you have to consult in the cloud, and it becomes a deeply embedded, localized utility running quietly inside your daily tools. Expensive intelligence gets reserved strictly for expensive problems.
Which really requires an immense amount of discipline from these companies. The future isn't a single monolithic superbrain. It's a vast network of highly competent, localized assistants working at the right cost, in the right place, with the exact right context.
Exactly.
It seems like the biggest players in the industry might be frantically chasing artificial general intelligence, the ultimate all-knowing cloud entity. But it sounds like the actual market is ultimately going to reward artificial specific usefulness.
I love the phrase. Artificial specific usefulness is what actually moves the needle for a business. The brutal physical reality of the infrastructure, the hard limits of our global power grid and supply chains, the staggering failure rates of enterprise adoption, all of these data points lead directly away from the giant centralized model.
And point straight through this layered, localized approach.
Exactly.
The path forward is completely different than what we've been sold. But as we wrap up today, I want to leave you, the listener, with a thought to mull over based on everything we've uncovered.
It's a big question.
It is. If the future of AI is truly going to be small, highly specific, and running locally on our own laptops and phones,
Right.
what happens to the massive tech giants?
Right.
These companies are currently spending trillions of dollars betting their entire corporate survival on renting out access to massive, centralized superbrains. When the rest of the world wakes up and realizes they just want a cheap, smart, localized delivery van, are the companies building billion-dollar race cars headed for a catastrophic crash?
It's definitely something to watch.
It sure is. Thank you for joining us at the table today. We'll see you next time.